Good day students, this is mathematics class for grade 10 chapter 1 real numbers. In this video session, let us learn the new topic under real numbers and that is revisiting irrational numbers. We know that real numbers are made of rational numbers and the irrational numbers. Also, we have studied how to locate irrationals on the number line. But we did not prove that they were irrationals. We will prove that root 2, root 3, root 5 are irrationals where 2, 3 and 5 are the prime numbers. While proving irrationals, we use fundamental theorem of arithmetic in our proof. So now what is a irrational number? A number S is called irrational if it cannot be written in the form P by Q where P and Q are integers and Q is not equal to 0. Before we prove root 2, root 3 and root 5 are irrationals, we need to prove one theorem which is based on fundamental theorem of arithmetic. The statement of the theorem is let P be a prime number. If P divides A square, then P divides A where A is a positive integer. So let me first take a general example to understand this theorem. Let me take one prime number 3. That is P is equal to 3 because it is given let P be a prime number. I will also choose A. A is a positive integer. So I will take A is equal to 6. That means A square will be equal to 6 square, which will be equal to 36. It is given if P divides A square, then P divides A. That is, if 3 divides 36, then 3 divides 6 also. If 3 divides 36, we get quotient as 12 and remainder as 0. And if 3 divides 6, we get quotient as 2 and remainder is 0. So this is a general example. Now we will write the proof of this theorem. What is fundamental theorem of arithmetic, students? It states every composite number can be expressed as a product of its primes. And in this, the factors are unique apart from the order in which they occur. So this is the statement of fundamental theorem of arithmetic. Now I am going to choose A, that is prime factors of A. So I have chosen A is equal to 6 in the example, and there 6 was not a prime number, isn't it? A is a positive integer, so 6 was a positive integer. So I can take the composite number also, that is 36. So here I am going to choose A, that is the prime factors of A. So the prime factors of A See, the prime factors of 6, are 2 into 3, isn't it? Yes. So here the prime factors of A, let me write. Prime factors of A. That is A is equal to P1, comma P2, comma P3, so on to Pn. And given that P divides A square, P divides A square, that is 3 divides 6 square, isn't it? P divides A square means 3 divides 6 square. So by fundamental theorem of arithmetic, every composite number can be expressed as a product of its primes, isn't it? So given that P divides A square, that is 3 divides 6 square. And here the prime factors of 6 are 2 into 3. So both sides squaring, we get 6 square is equal to 2 square into 3 square. So here it will be 36, which is equal to 2 into 2 into 3 into 3. So 2 2s are 4, 3 3s are 9, so 4 9s are 36, isn't it? Yes. So these are the prime factors of 36, that is 6 square. So by fundamental theorem of arithmetic, every composite number can be expressed as product of its primes. And therefore here P is one of the prime factors of A square. P is one of the prime factors of A square. Now here in this example, 3 is the prime factor of 6 square. 3 is the prime factor of 6 square. So here P is one of the prime factors of A square. So if P divides A square, so if P divides A square, P also divides A. P also divides A. Okay, which means that 3 is a prime number. 3 is a prime number. Also, it is a prime factor. P is a prime number and also it is a prime factor. Is this clear, students? Thank you, students.